Six pendulums of mass m and length L are shown or released from rest at the same angle theta from the vertical. Rank the pendulums according to the number of complete cycles of motion each pendulum goes through per minute. Rank from most to least complete cycles of motion per minute. To rank items as equivalent, overlap them. Here, 6 pendulums are given to us, whose length and mass are also given. And then we have to rank the frequency of these pendulums. We know that T is equal to 2 pi root L by G for a pendulum time period. Therefore, here for a pendulum at a given place, G is a constant. Therefore, T is proportional to root L. And then we know that F is equal to 1 by T, or F is inversely proportional to time period. Okay. So therefore, F is proportional to 1 by root L. Here, so the mass does not come into picture in this. Only the length will come into picture. Therefore, we have to find out the square root of length. Okay. So I calculated the square root of length and then I inverted it. Okay. So therefore, here it is. If you take this one, length 1 meter, 2 meters, 4 meters. So these are the numbers. So 1 by root 1 is equal to 1 and 1 by root 2 is equal to 0.7 and 1 by root 4 is equal to 0.5. So based on that, I segregated these things. If we see this one, the 1 meter, second one and the sixth one have the 1 meter length. Therefore, the frequency is 1 hertz. Okay, that is the highest frequency. And then next comes the third and fifth one. So length is equal to 2 meters. Therefore, the frequency is 0.7 hertz. Okay. And then the last one is first and fourth ones. So the frequency is 0.5 hertz. So the highest frequency is 1 hertz, and then the smallest or lowest frequency is 0.5 hertz. This is how I ranked the this ones. Okay, based on the frequency. Hope this helps. Thank you. Bye bye.